Okay, section 1.13, algebraic terminology. Let's look at, um, let's go ahead and look at the terminology definitions here. Let me fix my camera. Okay, a couple of things here. A constant is nothing more than a number. So this is where your, say, 1, 2, 3, 4, -2, -4. So that's what a constant is. Okay, so a constant is just a number. Is just a number. -1, 0, 1, 2, so on and so forth. Okay. Now a term is a constant or a variable or the product of a quotient. Okay, so this is already getting kind of confusing. Here's what you need to know about a constant, a term. Okay, a term is, it can be a product, and when I say a product, so let's define product. Product is the multiplication of two factors. Two factors being multiplied together. Okay. Now, the problem here is that back in grade school or middle school, whenever you learn this, they told you all these things, but they never really, like, they would tell you, maybe what a term is, what a product is, but then 6 months later, they would just assume you would know it, and then they'd go on to the next term. So it actually is pretty confusing. So a product, two factors being multiplied together. Example, 2 times 6 equals 12. So the 2 is a product. I'm sorry, 2 is a factor. The 6 is a factor. And the 12 is the product. Okay, so you have 2 factor times 6 factor equals a 12. Your result is the product. Now that works with algebra too. Okay, so if I have a 2 times an x, so I have a factor of 2, factor x, because they're being multiplied together, gives me a product. In this case, it's going to be 2x. This is considered one term. This is a term. This is a term. This term, because we don't have any x's or any variables, this is called a constant term. A constant just means number. Okay. The 2x term, this is a variable term. Even though it has constant in there, it has a variable. Variable trumps constant, so this becomes a variable term. Now, when you get into an expression, okay, an expression, it can contain, let's look at expression. So that's what a term is. Now, this 2, let me tell you one more thing about the variable term. This 2 being multiplied by the x, that factor 2, is also called the coefficient. Okay, so the 2 has two names. It's a factor and it's a coefficient in the product. Okay, I think we got everything for all of this. It's a little wordy. Okay, now an expression. An expression is a phrase that it can contain one term, whether it's a constant or a variable term, and has more than one term separated by addition or subtraction signs. So here's where it gets tricky. Okay, it can be the one term. Okay, so that's an expression. 2x is an expression. 12 an expression. What if I have 12 minus 2x? Well, this would be considered two terms. And here's what differentiates terms to just products. Okay. It's two terms because there's a plus or a minus sign in between them. Okay. If I just had 12 2x, that is one term because there's no plus or minus sign. No plus or minus sign. So that is one term. Two terms because I have a minus sign. Really confusing, and I don't think grade school or middle school ever clarified this, even high school. Okay, they just assumed that you knew all this stuff. Okay, so let's look at our expression here. We'll look at the expression made up of two terms. Okay, 12 minus 2x. Now, I'm going to throw an equal sign in there. Now, when I throw that equal sign in there, my expression, 12 minus 2x, becomes an equation. And of course, it became an equation because of the equal sign. Now, it doesn't have to have a variable. I could have 12 equals 36. That's an equation. It's not true, but it is an equation because I threw an equal sign in there. I can have one term equal one term. I can have 30 terms equal one term. It's still an equation. So that's the terminology that you guys are really going to have to really grasp all this, because when you go into college next year, they're not going to go over this. They're going to say, okay, simplify this expression, solve this equation. By the way, equations, excuse me, equations are solved. Okay, we solve equations. Expressions, we simplify or evaluate. Okay, simplify or evaluate. Many times you'll have an expression, they say, okay, evaluate it when x equals 2. You just plug in 2 for x and evaluate the expression. Here you solve it. Okay. Usually you'll have x equals a number. Not always, but most of the time. Okay, next page. An example of a constant is the number pi, which is 3.14159. And as everybody knows, it goes on forever and ever. It's an irrational number, but it's still a constant. Okay, it's a number. It's a decimal expansion continuing, here it goes, that repeats. We have the symbol pi to allow us to write the number exactly and whatever that word is. Secondly, even though in the number pi is represented by a symbol, it's still a constant, not a variable, because it's a number. A variable is a value, okay, has some value to it. Numerals like 4 functions in the same way as the symbol pi, just to symbolize a number. Okay. One way to make sense of the terminology is to use a Venn diagram. Now, I haven't done this yet, so let's see what happens here. It says draw a Venn diagram with one circle labeled constant. So I got a circle here, and I'm going to label this constant. Then it says, in the other labeled variable. Now, before I draw the other circle, it says decide if the circles will overlap or not before you draw them. If you can think of some characteristics that constants and variables share, then circles should overlap. In each section of the diagram, write examples and attributes. Well, I'm going to draw another circle, and we just went through this. So they have to overlap because we used the example, I think it was, what, 2x? Okay, that is a constant and a variable. So remember, this is variables. And again, just as the previous example we did on the previous page, like I used the constant 2 and the variable x, I multiplied them together to get 2x. Okay, so there's my example. If you can think of some characteristics. Oh, there you go. I guess I answered the question. Number 3, draw a Venn diagram once labeled expression. So let's do it again. Draw an expression. And the other labeled equation. Decide if the circles will overlap or not before you draw them. In each section of an expression, we used what, 12 minus 2x, right? And I'm not going to intersect them because remember, my definition was whenever I added an equal sign, it automatically becomes, so it's one or the other. So whenever I added an equal sign, no matter what's over here, I think I used 36. It became an equation because I added that equal sign. Okay, next. It says, understanding the differences between factors and terms is essential for the upcoming work we will do with algebra. Again, very, very confusing stuff. Remember, a factor times a factor equals a product. Okay, I can have 2 times 3, my product is 6. I can have the factor 2 times x is a product of 2x. Okay, got to keep those straight. All right, they give you another example here. For example, consider 3x minus 2y. There's by the way, two terms because it's separated by a minus sign. So there's 2 terms. The constant is 3, and so we have 2 products here actually, right? In each, so that's my coefficient, factor 3, constant. So we got a whole bunch of names. It's a coefficient, it's a factor, and the x is a factor too. Because I'm multiplying 3 times x. That's a product. 3x is a product. Same with 12y. Okay, so we got all kinds of things going on here. One term minus another term because it's separated by a minus sign. So I have term, 3, and the x are factors because the product is 3x. Same with the 12y. One more thing, 3 is a coefficient and 12 is a coefficient. Let's see, what do we got here? Um, they're just saying you can change the minus sign to a plus sign and put the negative with the 12. I think that's pretty straightforward. Whenever we have a number out in front of parentheses, we distribute. You can think of it as distribution. By the way, this is one term. This is one term. So we have two terms in this expression. It's an expression because no equal sign. Okay, next example. It says identify all the components of the equation negative 8x plus 1 equals 2x plus 6. Okay, so they give you the solution here, but we could do this. First of all, it's an equation because it has an equal sign. Okay, let's look at how many terms. Well, we got one term, it's separated by a plus sign. Here we have another plus sign. So we got 1, 2, 3, 4 terms. Okay, now let's look at each one of those terms. We have a negative 8. It's a factor. In fact, negative 8 is a coefficient because x is a variable, which happens to be another factor. Okay, so that's about it. Oh, nope, there's a 2x. So we have another factor. 2 is a factor. And the x is a factor. And actually, the 2 is not only a factor, that's a coefficient as well. Excuse me. All right, I think we got them all. Number 4. Let's see, complete the following table for the expression 2x times a quantity, x minus 1, divided by 3y plus 4. Classify each set of variables and or constants by their role in the expression. Okay. The 3 and the y. Well, these are factors because they're being multiplied together for this term. The 3y plus and the 4 are terms. They're two terms because they're separated by a plus sign. The 2 and the 3. The 2 and the 3, well, they're being multiplied, so they're factors. But each one of them also is being multiplied to a variable, so we could call them coefficients as well. The x and the x and the minus 1. The x and the minus 1. Now, you would think, hey, these are two terms in here. Okay, a lot of students will say, hey, those are two terms, but they're not. Okay, it's a factor. Because they're, note here, because of the parentheses, when I put parentheses around something, it becomes one number. It's called the quantity. Whenever I put parentheses around something, I can have whatever I want in here. 1 plus 2 plus x plus w. That's one term because it's going to be multiplied by something. Okay. Inside the quantity, I would have 4 terms. Very tricky. So I'm going to call this a factor because my quantity is being multiplied. In fact, this is all one term. Okay, the 2, the z, what else? The x minus 1. Again, because there's parentheses around the x minus 1, these are all factors. Inside the quantity x minus 1 are 2 terms. Confusing, huh? Even though overall it's one term because there's 3 numbers being multiplied together, inside the quantity are 2 terms. Remember PEMDAS, parentheses first. So you'll get a number out of this. Okay, next page. Just some more examples here. I think it'd be easier just to go ahead and do the examples. So multiplying 2 fractions together, I've gone through this before. It's going to be easier here to cancel out factors as long as one's in the top, one's in the bottom. It could be different or the same fraction. Let's see, there's 1 factor of 4 and 4, 1 factor of 4 and 4. There are 3 factors of 3, so 9 divided by 3 is 3, 3 divided by 3 is 1, 1 times 1 is 1, 3 times 3 is 3. Division of fractions. Change it to multiplication first. 4/9 times, flip the second fraction. Now, I can't cancel anything out. Don't cancel the 4s out and the 3 and the 9 because they got to be 1s in the top, 1 in the bottom. So I have 16/27. Okay, now I can't, whenever you see a fraction with 2 terms, put parentheses around them. Always do that so that you don't cancel out the 3 and the 9. Okay, you can't do that because now there's a plus sign. Here we could because there was multiplication. Here we can't because of the plus sign. So this, do parentheses first. 9 plus 4 is 13. That's your answer. Okay, polynomials. We all know what powers are. If I have 2 to the 4th, that means 2 is being multiplied by itself 4 times. Okay. 2 is the base, 4 is power, I'm sorry, the exponent, and the whole thing is called the power. 4 is the exponent, and 2 is the base. Okay, expression has only whole number exponents and variables, as in negative 27x cubed plus 12.5x plus 3/4. It's a polynomial. Okay, it's a polynomial because it has 1 or more terms. Now you got to be careful, but let's go through the different polynomials first. 1 term is called a monomial. 2 terms is called a binomial. And 3 terms is called a trinomial. Those are the most familiar ones that you've worked with in Algebra 2. For instance, 4x squared plus 3x plus 5, 1, 2, 3 terms, trinomial. Okay, the degree of the polynomial in one variable is the highest exponent that appears on the variable. Okay, so I'm looking at the variable. So if I'm looking at 4x squared plus 3x plus 5, it has a degree of 2. By the way, if the degree for a variable is negative, then it is not a polynomial. Let's see. When the exponent on a variable is written, the degree is easy to determine, but what about the exponent on a variable isn't written, or there is no variable? Okay. In the case of negative 7x, don't forget there's a 1 there for the exponent. So it's so we call that term, there's of the term is 1 in the case constant 4 point. So this is degree 1. This is called a constant monomial. If the expression is a polynomial, identify its monomial, binomial, trinomial, or none. Okay. And then identify the degree. So we got 1, 2 terms because it's separated by the minus. So this is 2 terms is a binomial. And for the degree, I look at the exponent of the y. So this is degree 2. Okay, B. Let's see, I've got 1, 2, 3 terms, which are trinomial. And look at the highest degree of the variable 2, so it's degree 2. C, 1 term, so it's a monomial. And it's called a constant monomial. Okay, D. 1, 2, 3, 4 terms. So this is, we're just going to call this, we didn't cover that, did we? Okay, well, anyway, it's called a quadrinomial. And look at the highest degree is 3, so it's degree 3. Okay, again, 1 term, monomial. Degree 1.5. Okay, I'm going to skip all the way to H. One term. This is a monomial. However, I have a problem because my x is in the denominator of the fraction. And the degree of the x in the denominator, there's a 1 there, degree 1. Okay, I'm going to mention something here. If I had something like, I'll call this I, if I had something like 1 over x, Remember our exponent properties. This is actually x to the negative 1. This is not a polynomial because of that negative exponent. Okay, I think that's it. Should be ready for your homework now.